Hello all, welcome to the 64-bit edition of the SecurityTube Linux Assembly Expert course and certification. Now in this video, we will look at loops instructions and how they can be used. Now the loop instruction really simplifies what we tried to do with the JNZ in the last video. The loop instruction uses the ECX register and it decrements the ECX register in every pass, and if ECX is 0 the loop ends, and just like in the last video you need to remember to preserve ECX through the loop. Variations include loopy and loop any, which I leave to you as an exercise. So let me open up program, call this loops.nasm, and here is what we are doing. We move the value 20 into RCX. After that we have our familiar hello world snippet in here, and then we basically go ahead and loop through the same hello world over and over again 20 times, and after that we exit gracefully. So loop is very simple to use. All you have to do is give it the label to which it needs to jump back and loop through once again. Now it's important to note that it is up to you as the programmer to preserve RCX through this loop. Now a lot of times, even though within the loop instructions might not look as if they are using RCX, but remember that when you do something like a syscall, it might no longer be preserved. And this is what we will prove and then fix this program. So let's go ahead and assemble and link it. And let me run this, and again we see our horrible little infinite loop. Let me load this into GDB. Break start, set disassembly flavor to Intel, run, layout the ASM, layout our registers, and let me do a step I. So we are moving the value 20 or hex 14 inside RCX, and after that we basically go through the print hello world syscall. Now notice that just before the syscall RCX is still 20, looks completely well preserved, but after the syscall, if you notice, it is all F's, and as you can well imagine, this would pretty much end up making this an infinite loop. Then we hit loop and loop goes back there, decreasing RCX, however to no avail, because when the syscall is called, RCX is again reset to all F's, right? So we need to preserve RCX just to ensure this works well, and the best way really is to use the stack. So push and a pop RCX, just like in the last video. Assemble and link it. Layout the ASM, layout the registers, step I. So we push RCX on the stack. After the syscall, of course, RCX is all F's. However, popping the old value of RCX back fixes this. Then we hit loop, which decreases it by 1. And then this kind of goes back, and as you can clearly see, 18, 17, 16, 15, blah, blah, blah. Pretty much just continue the program. And if we run loop all by itself, you would probably see that it goes ahead and prints this 20 times as expected, right? So loop makes life very comfortable. You can use it. Variations, as I said, loopy and loop any, look into them and see how you can play with them as well. I mean, it's quite easy, to be honest. That's all I have in mind for this video. If you're enjoying Pentester Academy, please do recommend us to your friends and colleagues in the InfoSec community. Thank you very much.